Assalamualaikum warahmatullahi wabarakatuh dan selamat petang. Like I already promised, so this is the video lecture for the IR spectroscopy. So on this Friday, we'll be having the lecture more towards the tutorial lah, because the preparation for you to face the test one next week. So for next week, akan ada soalan IR but only 5 marks. Okay, but still you have to go through in detail lah regarding this one. Okay. When we talk about the infrared spectroscopy, or nama pendek dia, usually I will call it as a IR spectroscopy. So I believe all of you already pernah dengar berkenaan dengan IR spectroscopy before, but mungkin you didn't learn yet in detail, right? Okay, so for the IR spectroscopy, I try to make it into two important. We call it as a session. The first one is a little bit on the theory of the IR, and the second one is data interpretation or spectral analysis. Okay, the most important one, of course, the data interpretation, because in this course you have to know how to interpret the data from the IR spectrum. Okay, bukan hanya tahu teori semata-mata like the topic of the UVBs and also fluorescence, right? Jadi for this video lecture, the first one, the part 1, saya akan fokus a little bit on the theory, yang mana tak banyak sangat, quite simple to understand. Okay, lebih kepada how IR works dan a little bit on the spectrum, the important thing on the spectrum. Nanti part 2 nanti saya akan go details on the data interpretation, dan kita akan continue on Friday how to interpret the data. For example, if you receive the question ataupun structure ataupun without the structure dan sebagainya. Okay. Okay, so IR spectroscopy, so we will try to relate with the spectrum, this is the electromagnetic spectrum region. Okay, so you are quite familiar with this one. For example, you have a UV visible here, and then from here to here we have infrared, yang mana the instrumentation of the infrared is focused on the mid IR. Okay, when we talk about the mid IR, so it will cover, okay, from this wavelength to this wavelength. So when we talk about the wavelength, in terms of the wavelength, of course, infrared have a longer wavelength as compared to the UVVs, and also lower frequency as compared to the UVVs. Okay, so that's why we have a frequency here, and then try to relate with the energy and wavelength. Another one here, you know that this is wave number. So why I have to make sure that you understand on the wave number. Basically, wave number is 1 over lambda, yang mana dia akan more focus towards the unit adalah centimeter -1. Okay, so why wave number is introduced? Because in the spectrum, okay, in the y-axis ni dia tak ada wavelength, okay, macam UVB semua, macam fluorescence. Instead of the wavelength dan sebagainya, so dia ada wave number which is in the unit of centimeter -1, because wave number is 1 over lambda. Okay, so that's why when wave number is higher, automatically the frequency is also higher lah. Okay, jadi apabila kita kata it cover mid infrared, so it cover start from 400 here 400 until 4000. But how the way, cara we call it as a spectrum is coming out from the detector. So it start from the highest first, which is 4000, and then go to the lowest one, 4000 sehingga 400 is here lah. Okay, so this is how IR spectrum is, we call it as macam mana IR spectrum is coming out from detector is something like this. So you have a transmittance, and then you have a wave number. Also you have a peaks. Okay, so this is where we try to relate with the spectrum. The region. So this is the IR region. Okay, and then when we talk about the theory of IR also, we supposed to know how the spectrum is coming out ataupun macam mana peak ini keluar. Okay, so when we talk about IR, so each of the peak here, we call it as a absorption peak. Okay, so kita ada banyak peak here, so that there are many absorption peaks. So what is referring to? So dia merujuk kepada apa absorption peak ni, ya. Okay, so for example you have a molecule. Contoh saya ambil satu molecule, you have a C double bond O, and then for example you have a CH3 here, and then you have a CH2 CH3. So this molecule, okay, kalau kita tengok kat sini, they have many functional group. For example, it has a carbonate, and then it has a CHsP3, for example, right? And then kita boleh cakap juga it has a many bonding, covalent bonding. Okay, C with the O, okay, C with the H, for example. Okay, so each of the absorption peak, basically each of the absorption peak here represent the functional group, right? Or ataupun kita kata the chemical bonding. Okay, specifically is a covalent bonding lah yang berlaku dalam molekul tersebut. So for example, you have a very complicated molecule. There are many bonding, banyak functional group involved. So you are expecting many peaks in the IR. But when we talk about the IR spectroscopy ni, it is a very unique spectroscopy because each of the bonding, for example, each of the functional group, for example, you have carbonate, you have hydroxyl ke, you have a C double bond C ke, so it has its own peaks pada frekuensi tertentu. Okay, because each of these we call it as a functional group ataupun each of this bonding, okay, require certain energy to vibrate, right? Because when we talk about the IR, we always talk about the vibration, right? Jadi dia memerlukan, okay, frekuensi yang tertentu, okay, the specific frequency to be vibrate. Jadi apabila dia memerlukan frekuensi yang tertentu, so each of the functional group will be having its own frequency, right? Contoh dekat sini kita tahu apa, dekat sini apa. So each of the molecule pun masih benda yang sama. Okay, so the way how do you collect all the data, which is you try to figure out, okay, what is important peaks that present in the spectrum, and then try to combine all the functional group involved. From that you can try to elucidate the structure lah. So this is how you are doing the IR. Okay, so IR spectroscopy ni, other than that, sebelum kita go for the instrumentation, so you know that you have the molecule, for example, ataupun you have the molecule that you didn't have what is the chemical structure, ataupun kita kata what is the functional group involved, you want to make a confirmation. So usually IR is the best instrument to send your sample lah. Okay, jadi the function of the IR, basically the main here is to determine the functional group present in the molecule. Okay, so this is the main function of the IR spectroscopy. Jadi for example, you are synthesis ataupun preparing the product, for example the chemical, so you know that you are combining chemical A with the chemical B, which is the reactant, and then the product is product C, right? Okay, so you know that chemical A macam mana, how it looks like, the chemical B, how it looks like, right? You know all the functional group involved. But for the chemical C, after you try to do it theoretically, so you're supposed to know this is how my product is macam kita kata macam ni lah produksi yang ada apa functional group dan sebagainya. So to make a confirmation, so you can go for the IR and then try to study berkenaan dengan all the absorption peak and then elucidate the structure to match with the one that you are expecting, for example. Okay, so that's the IR spectroscopy punya function lah. Okay, so when we go for the instrumentation, still talking about similar thing, masih cakap pasal benda yang sama, but the most important one when we talk about the IR ni, kita kata this one is focus on the vibration. When we talk about the UVVs, fluorescence semua, it more focus towards the electronic transition, right? What does it mean by the electronic transition? I hope you still remember regarding this one. So that means it needs the energy, it absorbs the energy, electromagnetic energy within the UVVs punya range, okay, to jump from the ground state into the excited state. So for the vibration, okay, for example, you have the molecule, and then you put the molecule in the sample holder in the instrumentation. Okay, so akan ada, so there will be several functional group, for example CO here, CH dan sebagainya. Okay, there will be a vibration once it's absorb the electromagnetic radiation from the infrared punya range. Okay, so like I already mentioned, for example, we always try to assume all of this, we call it as functional group ataupun bonding, the covalent bonding here. For example, saya cuba ambil satu contoh, which is you have a C double bond O. Okay, so this bonding, so you know that this is a carbonite, so you try to assume that you have a carbon and also you have an oxygen. Okay, so we always try to make sure that the student imagine this atom, two atoms here, a diatom here as a spring. Jadi kita selalu cuba assume this one as a spring lah. Jadi apabila kita kata you have a spring, right? Okay. So you have a two mass here, mass 1 and mass 2 for example. So this spring, okay, can stretch, right? Dia akan stretch and then dia akan going back to the original place. Okay, so this is how your molecule is vibrate. So macam mana dia vibrate? So you try to assume that it vibrates like a spring. Akan ada stretching, akan ada bending dan sebagainya. Okay, so when you try to put, for example, this molecule into this sample holder, so jadi akan ada dekat sini you punya sample. For example, kita nak more focus to the C double bond O. So like I already mentioned, each of the bond have its own frequency to vibrate. Okay, contoh dia kata dia ni, this is an example. Okay, so for example you kata dekat sini, for example you have a C and also you have oxygen. Okay, so you try to assume it's vibrate. For example, it can go for the stretching, contoh, ataupun kita kata it can bending. Okay, so nanti saya introduce a little bit lepas ni berkenaan dengan types of the vibration lah. Okay, to add your knowledge regarding this one. But first, you try to assume this one first. Okay, for example, to do the stretching, this functional group need, for example, it needs 4 Hz. So this one is a frequency. And then to do the bending, for example, it needs 6 Hz. So this is just an example. Okay, so you know that each of the functional group, like I already mentioned, to do the stretching ataupun bending, it has its own frequency. Berapa banyak energi yang diperlukan untuk melakukan vibration tersebut, right? Okay, so once you have the IR source, so IR source ni akan giving the frequency within the IR range, okay, from 400 hingga 4000 for example lah, in term of the wave number, tapi you can try to assume as a frequency first. Okay, for example, this IR ni, it start with the 2 Hz first. Okay, dia bagi 2 Hz the light to this molecule. Okay, and then when it's only give 2 Hz, but you know that to do the vibration, okay, so this carbonyl needs 4 Hz for the stretching and also it needs 6 Hz for the bending. So dalam arti kata lain, okay, the 2 Hz ni akan just pass through the sample, okay, but this functional group didn't absorb it. Betul? Sebab apa? Dia tak match with the frequency it needs to vibrate. Okay, jadi dia perlu match sebab dia dah tahu berapa dia nak. Jadi once light source give tu, dia terus ambil lah untuk dia terus absorb to do the vibration. But for here, because it's only give 2 Hz, but it didn't match with any of the frequency that it needs to vibrate, so it's only just pass through the sample. Okay, dia akan hanya pass through the sample. Dalam arti kata lain, it will just transmit, okay, and then it will be detected by the detector. Okay, sebab tu apabila you tengok the spectrum ni, saya lukis kat sini sebenarnya boleh je tengok kat sini, tapi it's okay, just put it in the other way here. Sebab tu dia punya data for the y-axis is the percentage of the transmittance, and then you can see that the peak is downward. Okay, because dia plot, okay, the spectrum is plotting the percentage of the transmitted. Okay, berapa banyak yang transmit. For example, you have a 2 Hz here, okay, and then 100% is transmit, right? Kenapa 100% is transmit? Because it didn't match with the frequency needs, so it will just pass through, and then it will didn't or we call it as a these 2 hertz takkan absorbed by the molecule to do the vibration, right? Because it didn't match with its frequency. Okay, so dia akan, for example, you akan just plotting something like this, for example 100%, right? Sebab tu akan ada yang akan duduk dekat atas ni, for example something like here. Okay, so you know that at this moment there will be no absorption happen, so that means the light source is just pass through the sample. Okay, but once for example it give you 4 hertz, okay, sebab dia akan keep giving from 400 to the 4000, right? For example tiba masanya 4 hertz, okay, one it go for the 4 hertz, so you know that it match with the frequency that need for the carbonyl to do the vibration, which is the stretching, so it will be absorbed the 4 hertz, the electromagnetic radiation. So once it absorbed, so there is no coming out, okay, transmit ni. Jadi sebab itulah apabila kita kata we have 4 hertz here, automatically it more towards 0 here. Okay, sebab apa? Jadi peak is something like this. Sebab apa dekat bawah ni jadi towards 0? Because ada berlakunya absorption. Right? So, jadi kalau semakin bawah ni, so that mean we call it as a strong peak. Why? Because absorption berlaku banyaklah that match with the frequency that it needs to do the vibration. Okay, so I hope that you understand lah kenapa peak ni ke bawah. Okay, what does it mean by transmittance? Okay, so the transmittance show how many percentage of the energy transmit, right? Okay, jadi when you have 100%, so you know that there is no absorption occur. When you have low transmittance, so you know that there will be absorption occur. So that means the functional group ataupun the bonding absorb the electromagnetic radiation to do the vibration, right? Okay. So when we talk about the vibration ni, so there are several vibration types of the vibration that occur in the UV, in the IR. Okay, so pertama kita ada type of the vibration. One we have stretching. Okay, and then the second one you have bending. Okay, apa yang saya cakap ni basically this is the overall apabila if you want to study, you are referring to the lecture note. So saya cuba try to come up with the simplest way to understand lah. Jadi you boleh baca, still boleh baca and then try to match back with the one that I explain. So lebih kurang sama. Okay. So of course you can refer to the YouTube, the banyak lagi video lecture lain yang to complete your understanding regarding this one lah. Okay. So type of the vibration, so you have a stretching and bending. So what does it mean? Like I already mentioned, you try to assume that your, for example here is a polyatomic, you have ada 2 atom yang mana diatomic yang mana dia berbeza, contohnya you ada carbon dan oxygen for example. Okay, so you try to assume this one as a spring. Apabila dia ada spring, dia akan keep going and then going, we call it as a stretch and going back, stretch and going back. So for example here, so there will be a movement, so this one we call it as a vibration. Okay, so how it vibrates? Okay, once for example the carbonyl, okay, receive the frequency from the sources, so it will be vibrate, right? Why? Because it absorbs the electromagnetic radiation that match with its frequency, right? Needs. So it will be vibrate. So macam mana dia vibrate? So it can be stretching and also bending. So stretching, we have a symmetry stretching and also asymmetry. Okay, lepas ni saya akan tunjuk supaya faham sikit lah berkenaan dengan ni. When you have bending, there are many types of the bending. For example, you have a rocking, you have a scissoring. Scissoring is like how the scissor is working. Macam mana scissor tu working kan? And then you have wagging, and then you have twisting. Okay, so it's quite difficult to look at just at the structure dan sebagainya. So kalau kat sini saya nak tunjuk satu, it's like an animation lah. As for me, I prefer this animation because it's easier for me to imagine lah. Okay, so when we talk about the symmetry stretching, so you can see that for example here you have a water lah kan. Contoh kalau kita kata kita ada water ataupun kita kata kita ada carbon dioxide, CO2. So you know that the center one, the yellow one is one atom. Okay, and then what does it mean by the symmetry stretching? So you know that both of these atom, okay, will be going in the same arrow. Okay, arah yang sama. Okay, jadi kalau you try to do it using your hand, so you try to assume that the yellow one is your body. Okay, and then you stay still, duduk senyap-senyap, and then your hand, one hand, satu hand, dan you ada the second hand, try to move in the same direction. So this one we call it as a symmetry stretching. Okay, so this is one example how the molecule ataupun the bonding is vibrate. The second one, it's possible for them to do the asymmetry stretching also. So it will try to stretch in the different direction. Jadi kalau you kata tangan you tu, satu bergerak ke atas, satu stay, satu bergerak ke atas, satu stay. So it will be asymmetric lah. Okay, for the bending, so dia ada twisting, rocking, scissoring and wagging. So twisting is like you twist lah. Okay, belakang depan. Kalau you use your hand pun, you akan put it twist. You twist your hand. And when you have a wagging, it's like wagging ni sebenarnya is like you try to move your hand together. For example, ke depan dua-dua ataupun ke belakang dua-dua, right? And then scissoring is like how the scissor is working. Okay, and then rocking is like macam buai lah, macam mana you try to hayun buai. For example, if you are familiar with the buai, I don't know, buaian, the baby is always sitting on the buaian, something like that, right? It's a rocking. Okay, so this is how the functional group is vibrate, each of the bonding. Jadi kalau kita tengok dekat sini, lepas ni saya akan ajar macam mana nak interpret the spectrum. Jadi selalunya we are referring to the table. So each table tu memang ada dah lah. For example, at a certain wave number, what is the functional group involved, and then is it stretching, is it bending, for example, right? So for no need for you to hafal lah. So this is stretching, this is bending, but as long as you understand how the vibration of the molecule ataupun the bonding is occur, ada berapa types, okay, this is an example dan sebagainya. Okay, so I hope that you really understand on this part. Okay, so for the theory of IR, last but not least, when you are referring to the table, to the spectrum, okay, lepas ni kita akan go through in detail. Saya cakap macam mana nak interpret the data, but the most important important thing here is when we talk about the spectrum of the IR ni, selalunya you try to separate this one. Okay, more than 1,500, here we call it as a functional group region, okay, and then less than 1,500, here we call it as a fingerprint region. So what does it mean? So basically the functional group region ni, this is the region that help us to identify our molecule, our sample, for example. Okay, so selalunya we are more focused toward the functional group region. Okay, when we talk about the fingerprint region, as we can see here, the peaks are quite messy. There are many noise. So fingerprint mean each of the organic molecule is supposed to have its own pattern for the fingerprint region. So dia akan berubah-ubah lah. Even though we call it as a fingerprint, it's better for us to know for each of the molecule, but due to the we call it as a peaks yang quite messy macam ni, so it's quite difficult for us to determine. So sesekali yang mana yang very strong tu kita boleh guna lah, but yang atas-atas there are many macam-macam ni it's quite difficult. So we usually try to focus more on the functional group region, which is 1,500 ke atas, more than 1,500. So from that we can try to combine all the functional group yang involved and then try to elucidate our data. Okay, so that's all for the theory of the IR. So nanti saya akan terus proceed to the part 2 yang mana saya akan explain briefly on the data interpretation before we go through in detail on Friday to answer each of the question together. Okay,